So this one that we're going to be looking at now is our web server. So this is our website. So this is the public facing website that, you know, the person will come to look at, you know, makervlog.com or something like that. It doesn't exist. You know, this is this external website. And for anyone not in IT is about to get very scared. Ooh, it's a command line. Looks very scary, but it's not. This is Linux. Linux is awesome. In an IT place, use Linux anytime you can. Whenever you can get away without using Windows, use Linux, because it looks really complicated. Believe me, I know it does, because it's command line. You have to type everything, but it's really not. It's really easy to use, and it's very easy to maintain compared to Windows. As you've seen, if you've seen the other few videos, you've seen Windows was, as soon as I logged onto it, it said updates available. Nightmare. And most of those updates are down to the GUI, the graphical interface that you're seeing. Linux does not have that. There is a version of Windows that you can use that doesn't have a graphics interface, and I'll show you that, because that's one of the things you can do to protect Windows. So Linux, very good, but this isn't actually what we're going to focus on, because everything's all set up, which is the beauty of Linux, especially for a web server. This is done. This is running. I don't need to touch it unless something breaks. But what is this running? This is what it's running. This is my website. That server is running a thing called WebGoat, which is an intentionally vulnerable website. So it's filled with holes, and it's built as a tool to help to let people get practice. So let me see if I register a new user, because I can't remember what my password was for the last one. So the server crashed. There's me bigging up Linux. It's because I logged into it. Whenever I logged into it, it cancelled my other session, which had this running on it, because I don't have it set up to run in the background. My fault, not the server. This looks really complicated. I know. If you ever want to make it look like something's really impressive, you just get Linux running and get it to do stuff like this. All this is doing is starting a program. If you've ever started a program in Windows and you get a wee spinny wheel that's waiting, it's actually doing stuff like this in the background. You just don't see it. And that's all it's doing. All of this is just saying what it's doing. So you don't need to worry about it. But once it says that it's up, we can then go onto the website. Okay, and there we go. See, it's up. So if I do username, let's go local admin. Just normal stupid password. That's my last pass, asking if I want to remember the password. We'll talk about password managers a bit more later, or see the other video where I talk about passwords. And this is the website. So this is simulating my external facing website. And the reason I used WebGoat is because I'm assuming that my external website is hackable in some way. Now, why is that a bad thing? Well, so here you can see, actually, if you've never used WebGoat and you want to get an introduction into how websites work and how to attack them, run WebGoat. Very, very good thing to do. If anyone is interested, put a message in the comments below, and I'll do a video showing how you can install this so that you can use it on your machine. But why is this bad? If I have a website that is vulnerable, what's the problem there? Well, if we look at my infrastructure here, this is blue, I believe. So if we look at my network here, you've got our file server, our domain controller, web app, and desktop. Our network is currently flat as a pancake. All of these computers can talk to every other one without a problem. They can just go between each other. There's no filtering, there's no rules, there's no protection. So having a website that is out on the internet, so anyone can access this website, and if that website is vulnerable, which most websites will have something, there is going to be something in the website that an attacker can exploit, depending on how determined they are. If it has a vulnerability, it's a tunnel into your network. They can use that as a jumping off point to get into your network and get access to everything else. Because it's flat as a pancake, they can just get into everything. They can get your domain controller. And as I talked about in the last video, you'll know that the domain controller is very important. You get hold of that, and you've got the keys to the kingdom. So that's why I went with WebGoat as an example of a website. So at the minute, flat as a pancake. If the website's compromised, they're into our whole network, and that's very, very bad. That's very bad. I cannot stress how bad that is. So that's the website. Again, if anyone's interested, let me know, and I'll do a video on how to actually install WebGoat. It is an interesting thing to use. But that's it. That's all the website is, and that's the issues with the website in our current network, is that if someone compromises it, they've got the whole network. Hope you're enjoying these compared to the brain dump that was the DC server. I hope it stressed how important the DC server is, though. Okay, so the next one we're going to look at is the web app, and I'll hopefully keep this in the same server, or in the same video. And the web app is here. And do you know what? I'm not even going to log into it because it looks the exact same as this. It's a Linux server. That's it. It's just running a website. The difference being is that it's a web app. Now, what's the difference between a web app and a website? Well, a website's public facing. A web app isn't necessarily. A web app is an application that is run in a browser. So if you think of Word or Photoshop or any program like that, it's run on your machine. Whenever you open it, it's your computer doing all the heavy lifting to do all the word processing or graphical processing, if it's like a Photoshop or whatever. Your computer's doing the heavy lifting. With a web app, it's running through a browser. So it's actually the server, the web server that's running that is what's doing all the heavy lifting and actually doing all the processing and stuff like that. So a lot of companies like using web apps for their internal applications. So say you're an insurance company, you might have an application that lets you log what policy someone gets a new policy. It lets you put in their name, their their insurance coverage, their details, all that stuff, and then it saves it to a database. And that's where all of your client information would be. And that's what a web app can do. And a web app is, as I say, it's nice because the actual end user's computer, so the person who's actually doing all the typing and working on it, their computer doesn't need to be that powerful. And so it then lowers the cost of that machine. And it means then it gives you a nice central place to administer these things. And I'll just show you what this one looks like. Again, I went for an intentionally vulnerable web app. So you can see here, this is BWAP. This was a bit of a right arse to install. Again, if anyone wants me to do a video on how to install it, let me know, and I'll do that. But this is an intentionally vulnerable web application, and I think I remember the password for it. Nope. Okay, let's just make a new user. Okay. So here is BWAP, now that I'm logged in. So this is a bit like WebGoat in that it's intentionally vulnerable, and it's built to teach people how to use these things. Now, some of the vulnerabilities are very similar to the likes of what you would see on a website. Again, the reason that I picked this is because this at the minute is set up really badly. Because a web app needs a database. Okay, and if you think of a database a bit like an Excel spreadsheet, it actually looks very similar. Operates differently, but there's similarities. And that database will hold all of your company's data. Again, if we go back to the insurance company scenario where you've got client information, customer details, policies, all that, a lot of personal information, and in some cases banking information, will all be stored in these databases. Databases should be encrypted and all that good stuff. The way I have this set up right now, if we go again back to blue, you can see I've got web app server, and that's where this web application is running from. You don't see a database server there, do you? No, reason for that is because it's on the web app server. It's on the same server. That's bad. Okay, that's bad practice, because let's say you've got your web application. Let's say it's not just an internal tool. Let's say you've got company partners that maybe also access this tool and use it to, you know, fill in other information. That's then a single point of failure. If that server hiccups for any particular reason, the database goes down with it. And that can cause corruptions and all sorts of mess. Whereas if you have it separate, you know, you don't have a problem. Again, if it's spread between multiple companies, it's then exposed to the internet in some way. Now, usually you'll have a thing called a VPN and stuff like that to protect it, but it's still more exposed. And it means if that one server is compromised, the database is compromised with it. And that can be not just from, you know, someone trying to lift data, but a ransomware attack. Okay, you could ransomware that, encrypt that entire server, and you've got the database at the same time. Whereas if you have the database separate and protected, and the protected is a key one, you know, if that web app gets compromised in any way, you can just shut it down, spin up a new one. The actual web app, the front facing bit of the web app, shouldn't be that heavy handed. It shouldn't be difficult to spin up because all the data is in the database. This one, as I said, I have it set up that all of that information, there it is, all of that information is stored on the same server. So that's something we're going to go through and do as well, and show how to split that out into a separate server, a separate database server, and then show how to protect it. Now, a lot of these servers and a lot of these things can be protected at a network level by putting in rules. The SQL server is no exception, or the database server is no exception, because it will communicate to the web application and send traffic back and forward, and, you know, update things. So say, okay, you've got a new policy holder, here's the information for them, and the database server will then take that and put it in there. But those transactions, you know, they're fairly similar. They have a similar construct. They look, you know, they look and feel the same. An attack will look different. And so there are things that you can put in both in the other applications that are watching the network traffic, which I'll show you how to install, and also network rules. So that's like, I only want this type of connection, this type of communication to happen. So the next video, or the next chunk of videos I'm going into, are going to be around the network and actually protecting that out, and starting to split these things up and actually put in some network level security. So hope you enjoyed. I hope it wasn't too much of a brain dump, even I did chunk them up a bit for you, so hopefully that made it a bit easier to digest. But if you have any questions, anything like that, please put them in the description below, and I'll answer them as best I can. So cheers, see you later.